Hi, this is a part 3, so we will learn how the temperature influence the equilibrium position. For analysis, this is what we call disturbance. So how to reduce disturbance and equilibrium position will shift to which part. Okay, now I start with the first disturbance is a temperature decrease. Temperature decrease. So how to reduce disturbance? You must increase your temperature. How you increase the temperature? You must go to the site which is a release heat, or we call exothermic process. So let's say you go to camping in the night, so very cool, right? So you need to increase the temperature with the put the fire. So that's why you need to go to exothermic site to increase the temperature. So how about the temperature increase? Disturbance temperature increase very hot. So you need to decrease the temperature by shift to the endothermic side. So endothermic side meaning that absorb the heat. So now we're talking about the system will absorb the heat from the environment. So now how about the K? The K will change because the law of mass action say the K will change when the temperature change. So only temperature will change the equilibrium constant. Okay, now I will using this diagram in the system to explain with you at the endo-exothermic process. If this one delta positive, meaning that this is a endothermic process. Endothermic process meaning that when A produce B, they will absorb heat. So A will absorb the heat and then to produce B. So this is the concept. A will absorb heat, produce B, called endothermic process. Okay, now how about reverse? Reverse meaning that exothermic process. Exothermic process meaning that B produce the A, you will release the heat. So release the heat. Yeah, so B will release the heat to the system. So at this condition we call equilibrium. How about the when temperature increase? So this is called disturbance. Temperature increase from the 27 to 100 degrees Celsius. You can see more heat in the equilibrium system. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So more heat now. So because temperature increase. So how we decrease the temperature, right? How we decrease the temperature? So we must absorb the heat or release the heat. So the answer is we must absorb the heat so that the heat at the surrounding decrease. So to absorb the heat, we must shift to the endothermic process. Okay, now if endothermic process happen, meaning that A produce B, you absorb the heat from the surrounding. Okay, you can see the number of heat already decreased, meaning that the temperature now is decreased. So this is a process. So this is an explanation. When the temperature increase, you must decrease the temperature. Go to the side is absorb the heat or endothermic process. Next, how about the disturbance is a temperature decrease? Okay, now temperature decrease from 27 to 10 degrees Celsius. So now is a less number of heat, right? Okay, now you need to how to increase your temperature again. So you want more heat. So that the answer is should be you want to produce more heat, that means the answer should be release the heat. So you shift to the exothermic process. So from this equation, you will find the exothermic process on your shift to the left side. So now what happened to B to A? So when the B produce A, you produce more heat. So at the end, you will find that the temperature will increase. So this is an explanation using the analogy heat. For the thermochemical equation, first you must know how to interpret the information. If this one negative, meaning that the forward is exothermic and reverse is endothermic. If this one is meaning that positive, meaning that the forward is endothermic and the reverse is exothermic. Now we'll study the two case more. First one is in cooling reaction. So cooling reaction, right? This is a cooling reaction. So meaning that the lower the temperature. So this is your disturbance, lower the temperature. So how to reduce the disturbance? You must increase the temperature. Increase temperature meaning that you must produce heat to the surrounding. So equilibrium portion will shift to the produce heat or exothermic process. This one is a exothermic process. Okay, now for when you get the equation, first analysis. Positive means this is a endo and this is a exo. So we find where is the process of exothermic. The answer is you will shift to the left side. So for this question, you will shift to the left side. Okay, now how about the second equation? So if they give you the equation is a negative, meaning that forward is a exothermic and the reverse is a endothermic. So we want to produce a heat. That means the system must shift to the system must shift to the right side. The system must shift to the right side to produce a heat. So student, you can check, is it this one heat release? Is it this one heat release? This one? And this one also heat release, right? Yes. So meaning that you remember in decrease temperature to increase temperature must go to the exothermic process, so they can produce more heat to the surrounding. Okay, next example is you heating the reaction. So meaning that the increase temperature. So this is called disturbance, heating the reaction. So increase the temperature. So you must reduce the temperature. So how you reduce the temperature? You must consume the heat. Another meaning, absorb the heat. How we absorb the heat is endothermic process. Okay. So maksud kita serap tindak balas akan serap haba dari sekeliling menyebabkan suhu turun. So it's called absorb the consume the heat. Okay, now so let's say they give you this equation endothermic, meaning that forward is a endo and the reverse is a exo. Okay, so where is the direction endothermic? So the answer is shift to the right side. So for this answer, they will shift to the right side. Okay, now how about the second equation? If they give you negative, that means forward is exo and the reverse is endo. Okay, now so where is the direction of the endo? So the answer is shift to the left side. Okay, you can see, right? You can see the process of a reactant using the heat will produce the product. Means that the reactant will absorb the heat from the surrounding and then produce a product. So that's why the temperature will decrease. Okay, second one is the product. The product will absorb the heat from the surrounding, so produce the reactant. So that's why the heat will decrease, temperature decrease. So conclusion, for increased temperature disturbance, you might decrease the temperature by shift to the endothermic process. This is experiment 6 chemical equilibrium. So this one we call pink color for the hexachlor cobalt 2 complex ion, and this one we call tetrachlor cobalt ion. So when these species combine together, the solution combine together, they will form the purple solution. This is at equilibrium condition. Okay, now so the reaction forward is positive. That means that forward reaction is an endothermic process and the reverse reaction is an exothermic process. Okay, now so we study this is a disturbance heat. That means we put in the hot water. So this is a hot water. So now temperature increase. So disturbance. So how to reduce the disturbance? We must decrease your temperature. So how? By using go to the endothermic process. Okay, now class, you can check where is the direction of endothermic process. The answer is right side. So that means the system will shift to the right side to achieve equilibrium. So once they shift to the right side, you will produce more blue color. So you can compare the purple will change to blue color. Okay, this is the first one. Okay, now how about the system I put in the ice water? This is the ice water. So that means the temperature decrease. So the disturbance now is a temperature decrease. So how to reduce the disturbance? You must increase your temperature. How you increase your temperature? You must shift to the exothermic process. Okay, now class, we check where is the exothermic process. Okay, so here. So the system will shift to the left side exothermic process, then it will produce a more pink color. So you can see the observation is purple change to the pink color. Okay, alright, okay, now is our last slide, which is I discuss how to do the explanation. So hopefully you understand the concept first. Now first analysis. Positive means this is a endo and this is a exo. Okay, now first you must understand the 1, 2, 3 first, then you look at the equation. Temperature increase is your disturbance, so you need to decrease your disturbance by decrease your temperature and shift to the endothermic process. That means you want to consume the heat. So the first sentence is a disturbance when temperature increase. Second is how to reduce disturbance. The system will reduce the disturbance by increase the temperature, which is a shift to the endothermic reaction. Okay, this is the second sentence. Now we check the equation back. So according to the equation, since the forward reaction is endothermic, so equilibrium portion will shift to the right side. So once they shift to the right side, right, so amount of product will increase, amount of reactant will decrease. So you can predict the K by using the K equals to product over reactant. Okay, actually they have another theory. So you can predict like this. Once the product increase, reactant decrease, that means your K over increase. Okay, now how about temperature decrease? So temperature decrease is your disturbance. So very cool now. That means you must increase your temperature. How you increase your temperature? You must shift to the exothermic process where it release the heat to the surrounding. So how we do the explanation? First one, when temperature decrease. The second sentence, the system will reduce the disturbance by increase your temperature. We shift to the exothermic reaction. Yes, understand the concept first. Then you can refer to your equation. Since the forward reaction is endothermic, or you can say the reverse reaction is exothermic. So meaning that equilibrium position will shift to the left side. So once it shift to the left side, the mean side product will decrease and the reactant increase. So how about the K? You can assume product over reactant. So product decrease, reactant increase. That means your equilibrium K will decrease. So this is a simple method, but actually they relate to another rules. So hopefully you enjoy the discussion where you must understand the concept first. Temperature increase, you need to reduce the temperature and go to endo. Then you refer the equation where is the endo. Alright? Okay, come. So hope you enjoy the class. Thank you, class.